Now, coming to the preparation of glucose, as I said you from sucrose, how will you prepare it? That is C12H22O11, C12H22O11 plus HOH in presence of H plus. What it will give you? C6H12O6 plus C6H12O6. One is your glucose, another is your fructose. One is glucose, another fructose. One is aldoses, another ketoses. Alright, you will be getting it. Clear in this way. So we can also prepare it from starch. C6H10O5 whole N. This is your starch. It is a polysaccharide. We have read it now, just now. Now, when it reacts with N molecules of water under certain conditions. So the conditions here will be in presence of acidic medium, and that is around 393 Kelvin and 2 to 3 bar pressure, atmospheric pressure. Alright, 2 to 3 bar atmospheric pressure, 393 Kelvin will be getting it. So what you will be getting? The product as glucose, N molecules of C6H12O6, so to say, N molecules of C6H12O6 I will be getting it. So in this way you got glucose. This is starch. From starch upon hydrolysis will give you nothing but glucose, so to say. Clear? In this way you will be getting it. Now we have seen the structure of glucose already. We have seen it, the open chain structure. We can also write the glucose structure in this way: CHO, then CHOH whole 4. There are 4 CHOH molecules are there, and then CH2OH, isn't it? We have seen it. Count it, you will be getting C6H12O6. See, here it is 1C, then 4C. 4 plus 1, 5C plus 1C, 6C. 12, you can say that, count it and see. Here 4 2s are 8, 1 9, 9 3, 12 hydrogen. Here 4 oxygen, 5 1 6 oxygen. Done. So this is also a structure of glucose. It's a condensed formula of glucose, we can say that. Clear? So we have seen the open chain structure, we have seen the condensed formula structure, we have also seen the cyclic structure, which I said, there is pyranose structure and the furanose structure, we can say that. Clear? So that is the closed chain structure, we can say that. With the cyclic structure, we can say that, the pyranose structure or the furanose structure, so to say. Clear? And the molecular formula of the glucose, you know it is glucose and fructose, both are same, that is C6H12O6, so to say. Now when glucose it undergoes that is reduction, we can say that. Clear? When glucose undergoes reduction, that is CHO, then CHOH whole 4, alright, single bond CH2OH, when it undergoes reduction in presence of HI. Alright, HI is a very strong reducing agent. It's a very strong reducing agent. It is being heated. But I am going to get it. I am going to get simply nothing but hexane. It will break up completely. It is nothing but aldehyde and alcohol is there. So aldehyde and alcoholic group. The primary group is your aldehyde. Functional group, I mean to say. So that will be reduced to alcohol. Alcohol will be further reduced to alkanes. So hence you will be getting nothing but is your hexane. You will be getting it here because 6 carbon is there. So it is nothing but you will be getting hexane. That is C6H14. I am going to get it. Plus H2O plus I2. The secondary product you will be getting it. Plus H2O plus I2, because oxygen is there, it will react with hydrogen to form water and iodine will be released. We can say that. Clear? Now, next, this is one reaction, you got it. Another reaction, that is when glucose reacts with, that is hydroxylamine, NH2OH. When glucose reacts with hydroxylamine, that is NH2OH. So, what I am going to get it? I am going to get that is nothing but CHO, single bond, CHOH whole 4. Then what I am going to get it? It will be, that is your CH2OH. That means what? Nothing is changing here. What here? See here. That is CHO. That is CHOH whole 4 single bond CHOH. So is it the same product I will be getting it? No. So NH2OH, then what it will do? NH2OH will react with aldehyde. We have already seen it in the aldehyde chapter. What will happen? This NH2OH. Rather, I should write it in this way. No, I should write it in this way. Why? Because this water will be released. And when this water is released, what I get the product? The product is CH double bond NH. This is your answer. We should write the reaction in this way. Just to remind you, I wrote it first in H2OH. So we should not write in this way. I have told you in aldehyde chapter if you remember it. So this is your nothing but you got the answer, that is an oxime. Or oxime, whatever you can say that. Clear? So when it reacts with HCN, when it reacts with HCN, hydrogen cyanide. So what I am going to get it here? It is nothing but CH, one bond with OH, another bond with Cn, and here it is CHOH whole 4 and single bond CH2OH. You will be getting it. Clear? So this is nothing but a cyanohydrine. This is a cyanohydrine, we got it. Glucose cyanohydrine, and this is your nothing but glucoxime. An oxime, we got it, or glucoxime, we can say that. Clear? So in this way we got the product. Now next is when it reacts with bromine water. Now you know bromine water acts as an oxidizing agent, isn't it? Bromine water, that is your aqueous bromine, it acts as an oxidizing agent, bromine water. So when glucose CHO single bond CHOH whole 4 single bond CH2OH, when it reacts with bromine water, or we can say aqueous bromine, we can say that, which acts as a nothing but oxidizing agent. How? Because bromine water is what? HBRO. HBRO will give you nothing but HBr plus nascent oxygen. So what will happen? CHO in presence of nascent oxygen will be oxidized to acid. So COOH plus I'm saying single bond CHOH whole 4 single bond CH2OH. Alright, so this is what? This is nothing but, it is known as gluconic acid. Gluconic acid. This is known as, because acid COH, it is nothing but acids, it is gluconic acid. Clear? Similarly, when it reacts with acetic anhydride, alright, you will be getting a pentacetate. You will be getting it. That is, here you will be getting CHO. Same thing, here it will be CHO. Here it will be nothing but CHOCOCH3 whole 4. Alright, COCH3 whole 4, single bond CH2OCOCH3. Again I repeat, when it reacts with acetic anhydride, what you will be getting? You will be getting here CHO, single bond CHO, C double bond O, single bond CH3. Again I repeat, CHO, single bond, that is, let me write better, CHO, single bond, that is CHO, then C double bond O, CH3 whole 4. Alright, that is CH3 whole 4. So single bond, what is that? CH2O, C double bond O, CH3. That is CH2O, CO, CH3. We can say that. So in this way we got it a pentacetate. 5 acetate group is there. This is one acetate, 4 acetate, this is one acetate. So you got a pentacetate. Clear? Similarly, if you are oxidizing glucose in presence of nitric acid, alright, then first you will get saccharic acid, and then after that you will be getting gluconic acid. First saccharic acid, then gluconic acid. Let me write this. That is glucose when it is oxidized, that is CHO, single bond CHOH whole 4, single bond CH2OH in presence of oxygen. Oxygen from where will I get? That is, I will be getting it from dilute nitric acid. We can say that. Dilute nitric acid. So what I am going to get it? So nitric acid acts as an oxidizing agent. You have seen nascent oxygen. So aldehyde will be oxidized to COH. And here you will be getting it nothing but CHOH whole 4. And here also you will be getting, that is your COOH. Here also alcohol will be oxidized to aldehyde to acid. So hence COH. So this is your saccharic acid. Saccharic acid. Plus, alright, plus what you will be getting? Plus you will be getting, that is nothing but COOH, single bond CHOH whole 4, single bond CH2OH. That is CH2OH. This is called as gluconic acid. This is known as gluconic acid. You will be getting it. Where this is the major product, this is your minor product, so to say. So in this way, these are the properties of glucose, which I said you, the properties of glucose. Now, next is in this way, we'll come to another one, mutarotation, another properties of glucose. That is the spontaneous change in optical rotation of an optically active compound in aqueous solution with time and equilibrium is called as mutarotation. Again I repeat, the spontaneous change in optical rotation of an optically active compound. Spontaneously, the change which is taking place means from D to L or from L to D. whatever you can say that. In aqueous solution with time and equilibrium, to value is called as muta rotation. With time it attains equilibrium. With time and equilibrium means with time it attains equilibrium. Alright, from one form to another form. Now D to L we can say that. D to L means your dextro and levo. Small d and small l, not capital D, capital L. Okay, so that is called as what? Muta rotation, so to say. That phenomena is called as muta rotation, so to say. So in this way, it can also react with concentrated nitric acid. We can say that glucose to give you what you can say saccharic acid. We can also say that as you can see dilute nitric acid reacts. It can also react with concentrated nitric acid. Also it can react. It can react with Tollens reagent to give you what? Silver mirror. It can also react with filling solution to give you what? A reddish brown PPT. Alright, glucose, noted this one, very very important because it's a test for glucose. It will react with Tollens reagent to give you silver mirror. It will react with Fehling solution, Fehling A as well as Fehling B, and you will be heating it. You will be getting a reddish brown PPT, that is Cu2O, you will be getting it. Clear? So, if it is reduced in presence of sodium, amalgam and water, it will give you what? That is nothing but sorbitol. Sorbitol is what? CH2H, single bond CHOH whole 4, single bond CH2H. Again I repeat, CH2H, just simply CHO will be reduced to CH2OH. CH2OH, CH2OH, single bond CHOH whole 4, single bond CH2OH. What is that? That is called as sorbitol, we can say that. It is known as sorbitol, we can say. Clear? So in this way, when glucose is reduced in presence of sodium, amalgam and water, what we get? Sorbitol. The formula is, again I repeat, CH2OH, single bond CHOH whole 4, single bond CH2OH, because aldehyde is reduced to alcohol. I am going for reduction. Similarly, if it is reduced completely, I have already said, you will be getting hexane, we can say that. Clear? Fine. So it reacts with hydroxylamine to give you glucoxime. It reacts with HCN to give glucosinohydrin. In this way, it reacts with what you can say PCl5 to give you nothing but pentachloroglucose. It reacts with PCl5 to give you pentachloroglucose. Like CHO, single bond CHCl whole 4, single bond CH2Cl. That is your pentachloroglucose. Again I repeat, CHO, single bond CHCl whole 4. Instead of CHOH whole 4, I will be writing here CHCl whole 4, single bond CH2Cl. When we get it? When glucose reacts with PCl5, it gives you pentachloroglucose. I hope you are getting it. Similarly, when glucose reacts with calcium hydroxide, glucose, it gives you calcium glucosate. Calcium glucosate, that is C6H11O5 OCaOH. C6H11O5 OCaOH. Alright, that is your calcium glucosate. We can say that. When we are getting it? When glucose reacts with calcium hydroxide. C6H11O5 OCaOH, calcium glucosate, which is also a white colored PPT. You will be getting it. We can say that. Clear? So in this way, these are the different reactions of glucose we are getting it. Now there are certain differences between glucose and fructose. Like glucose, it reacts with what you can say silver mirror, it reacts with bromine water, it reacts with Fehling solution, and we got the product. But fructose has got no reaction upon bromine water, we can say that. It does not decolorize the bromine water. Like suppose in glucose, you have seen it. When glucose reacts with bromine water, the bromine water get decolorized because we get acid, which is that nothing but saccharic acid. You will be getting it, gluconic acid. You will be getting it. But what you find is that got it in bromine water also. It gives you saccharic acid and what you can say gluconic acid, where gluconic acid is a major product. But with concentrated nitric acid or to dilute nitric acid, you get saccharic acid and gluconic acid, where saccharic acid is a major product. Okay, it depends from reaction to reaction. Now this all reactions is not given by fructose. Fructose does not give this reaction. Fructose does not give the reaction of what you can say Tollens reagent or Fehling solution. Rather, it gives a furfural test. On boiling fructose with alcoholic alpha naphthol and concentrated HCl, or purple or violet coloration is observed. Again I repeat, on that is heating or on boiling fructose with alcoholic alpha naphthol, reagent is there, alcoholic alpha naphthol and conc HCl, a purple or violet coloration is obtained. We can say that. That is called as furfural test, F-U-R-F-U-R-A-L, furfural test, which is given by fructose only, not by glucose. Glucose gives bromine water test, which decolorises bromine water. Glucose gives Fehling solution test, which gives reddish brown PPT. Glucose gives silver nitrate test, that is ammoniacal silver nitrate, which is called as Tollens reagent test, which gives you silver mirror. Upon heating begins that. Clear? Now this is about your glucose and fructose. This is the difference between glucose and fructose also you saw. What it glucose gives which test and fructose gives which test, you saw it. So this is I was talking to you about monosaccharides till now. I was talking to you the preparation of glucose, the structure of glucose, the structure of fructose, alright, the properties, differences, everything I said you. Alright, clear? Now we'll come to disaccharides in the next video.